Then actually, um, there are a number of projects that I think we will be able to fully take you advantage of your facilities. And the one we are discussing is a continuation of a project with GSK on tick-borne diseases. And the one which we're testing is a part of the cross-validation of the platform we have built for Hungary, and would like to cross-validate this using the data from China and hopefully scale up to the whole European continental. I have also briefed the Canadian Lyme Disease Association with head office in Kingston, actually. And I told them it's a potentially very effective computing platform for us to run the Lyme disease modeling in Canada. The Lyme Disease Association, Lyme Disease Research Network, actually, was recently funded by the federal government, led by Carrie Murray from Kingston, and it's a national network with all provincial and territory networks, agencies involved. So this is going to be already a pretty ambitious national, international collaboration, and that's the one Nazina and Kyuga are trying to develop a platform to run the data. And we do have some other major developments involving Sanofi, that's another, the largest vaccine provider in Canada, on a variety of infection disease modeling. All will require very intensive computation and data feeding. Right now, we're doing a couple of projects involving the mass gathering, especially the HASH, in collaboration with the Saudi Ministry of Health. That involved a collaboration with Google. So we're in the process of finalizing the agreement with Google mobility data. And hopefully this can be used to really inform intensively in real time the mobility pattern, so we can plug in to particular infection disease modeling to really near casting the disease trend during mass gathering. Mm-hmm. Another project we're working is on collaboration with, actually with you, KFLA Health Network. We are signing agreement to have access to all the emergency data, especially those data from the emergency departments, and in the hope to track and do real projection on flu and other respiratory diseases. Again, this involving collaboration with Sanofi and with national networks. One thing I will talk with you then a little bit is we are developing a very ambitious program to be funded by tri-councils, the insects, HR, and SHRP all together. I don't think that we can get full project. It's the tri-council is going to fund only one training program across the country with a $5 million budget, and I think we are developing a project involving simulation of the variety of diseases and natural disasters in urban cities. And we are thinking about taking the floods as a starting point and focus on the flood-induced foodborne, woodborne, and vector-borne diseases. So this game, we're going to put a proposal. This is a training program. I don't think we're going to be the sole owner of the program, but we're trying to get into that. Eventually, I think the government is probably going to break up the whole program into 3 pieces. Hopefully, we can take care of the disaster emergency rapid response simulation part, because that's one I think York has unique strengths. So that's something we can talk to you. And then I have a meeting with the 3 co-PIs today, and I can get back to you.
Wonderful.
And I suggest we focus on the vector-borne diseases today, especially the tick-borne diseases.
Absolutely. Thank you for that overview. Very, very excellent list of projects you're working on, very ambitious. And pending the results of this demo, we would love to continue to be involved and to play our part. So that's it. Thank you. Nazila, over to you.
Yes. So the demo is going to be important for us as well to show to our partners.
Thank you so much for your time and Kyunga today. I'm so excited to show you how to use the application. Let me share my desktop. So if you have my desktop, to use the application, it is easy. You should just type tde.distributed.computer in your browser. And after that, you will have access to the application. The application is exactly based on the code that I was given by Kyunga. You need to provide a start date and end date for the data for the trajectory. So, for example, it is default by the code 1991, and after that 2008 to make the trajectory. And after that, we need to provide a starting time for the model and time step. Also, we need to provide two types of data. One of them is weekly report of temperature, which I have here, and also weekly report of the incidence of TBE that I uploaded here. So uploading all the data, the next step is going for the initial search. I have all my parameter here. For example, P is maximum number of eggs, and then I can define the parameter to be fixed or to be estimated. For example, for omega, which is degree of density, it is considered to be estimated. So if it is estimated, it should have a range, and we need to provide lower and upper one for the range. And if it is fixed, it is only value. We can change the fixed value to the estimated, and then again provide the range for all of them, or just keep it as a fixed variable. For the estimating variable, it's really important to mention if it is always 0 or it is a probability. And if it is a probability, it should be between 0 and 1. Like what we have here for FL, which is probability, and we consider this one as a flag between 0 and 1. Right now, there is nothing to do or change because they are all default based on the code. Or for your future reference, if you want to do any changes or change any other parameter to be fixed or to be estimated, it is possible through this page. Having all the parameters and also the states, the next thing is pushing generate the model. And it is like making pump. For the first run, we can start with 10,000 or any number that you want. And by pushing compute button, it generates 10,000 points based on Sobol function and start calculating all of them on the cluster. I don't want to make the cluster busy, so let me just do with like 40 points for now. Pushing compute button, upload key store pop-up, and it is like providing money for the application to start working. It is easy to work with this. We need only to provide and browse and upload the file, which I have here, and I think Dan provide you with one.
Yeah, we wonder how we use it.
It is just one time uploading here, and now all the 40 points are going through the cluster, job accepted, and start working. Soon I will have the result pop up in this page. The first search is really critical because the more points, the better results. So whatever you want, you can start from this page. Like yesterday, I started with 4,000 points, and then when it is done, we can download the result and then go to the refinement.
Well, yesterday when you run the 4,000 points, how much time it takes?
For example, for me, yesterday it took about 1 hour, but it depends on how many cores we have. I think Dan can explain better.
Sure. Professor Wu, we ran 4,000 points on approximately 85 CPU cores, but it's trivially easy to connect more. And I wanted to talk about this after this discussion. The idea is to go to York U and talk to the IT staff,
Right.
and pick up 5,000 to 10,000 CPU cores, all of the idle machines and the computer labs. Essentially, because your problem, each of these points are computed completely independently one of another, it doesn't experience parallel slowdown, which means that the more cores, the faster it goes.
Uh-huh. So right now, Nazina, so you're using the core from Kingston?
Yes.
Or from within your in-house?
The cores, the CPUs are in-house right here.
Okay.
So for the next part, for the refinement part, we need to upload the result from the last page that I have it here as a TBL. As soon as I upload them for each of the parameter that needs to be estimated, I can have the profiling graph exactly here that helps you to see the behavior of the points, if they're really noisy or if they're smooth enough. And then as Kim mentioned last time, automatically we have new bound for new search. Or even you can check the graph and make a decision, like for this one, maybe between 10 and 40, and start with, let's say, 1,000 point again, generate and run. Accessing distributed computer, and all these 10,000 points, all these 1,000 points are accepting and working. We are waiting for the result. Let me do that with another point as well. Let's go through, for example, FL. FL is probability, and the interval which is suggested is between 0.6 and 1, which seems good because we have the best point here. Again, I'm going to generate 1,000 points. And as soon as we have the best result come back from the cluster, by pushing best result, all the best points with the highest maximum likelihood from all these refinements get together in this bottom and just gives us the best result. Also, I provide another button here as a download button separately for each of these parameters. If you want specifically go through them and see the result and see how they are working. Otherwise, the only thing that is really important is the best result. The result come back, the first one from the cluster, second one, and go on. At the beginning, we should they have delay, something like a minute to getting to the cluster, and after that, they're really fast. As you can see, they're coming back very fast. Now, if I push best result button, you can see that even the graph has changed based on the point that we recently received from the cluster. So I have another good point coming back from the computation. And then in the sample trajectory, there is the data and trajectory plot based on the best point that up to now we have.
So this one is, can I know the likelihood?
For this one, the likelihood, okay, if you want to know the likelihood, we should open this one. And let's say the likelihood is -8580. I can make, maybe it's a good idea to, for this point, just have all the parameter and likelihood written here, if it works.
Mm-hmm. That would be good.
Okay, sure. Sure.
So
I will.
now, yes. Go ahead.
Yeah. So I just wonder, can we know like how many iterations or like sampling, desampling has been through to get this?
Sorry, I can't hear.
Say pardon me. I can hear that.
Sorry, I can hear that.
Oh,
Right. Sorry,
yeah,
can you stop typing? Excuse me.
So I thought to get this result, I thought you got repeated sampling process, right? If I understood well.
Could you please read?
So how many times did you run Sobel function?
So these results based on 4,000 points in the Sobel function and one more time refinement.
Aha, okay, I see. So it will be better. The likelihood will be better if we run more and more time.
Yes, yes. Especially, I think the first run, like the Sobel one, is really important because it is the first time that you search the space. So the more, the better. And after that, the first refinements, it is only refinements for omega that we have right now, right? It is for omega, and also I think I run FN. Yes, I run FN. So it is only for these two. Then if you start and refine it for all of them, for sure the result would be way better than the result that we have here.
Mm-hmm. Right, thank you.
So this technical one. So this refinement process is one should do that manually and instead of automated fashion, or you can make it automated.
We can do and make it automated.
Okay.
If I can jump in, I believe the current state of the art, people do these refinements manually through RStudio or whatever their programming environments are. What we did was we took their previous environment, we put it into the web browser for an easily point and click usability. More automation can be done. There's a ton of things that can be done here, like it can be done in the previous code. But we were excited to explore and show how using a single link to a web browser application that can be opened on a phone while sitting on a bus, on a Mac, on Windows, like anywhere in the world, like you can send this to any of your students and anyone can instantly start doing TB modeling. And all the results get downloaded. So that's sort of what we want to show. Now, the more exciting thing is that if we go to York University campus and we hook up 10,000 computers, well, you have 10,000 times more power. So there's a lot of advantages to this computing platform for all types of related research.
I agree. So it's very good for for also the classroom presentation. So student can run it, can show it, and you can present one single simulation, and this is very fast. So Nazina, are you running this on real time?
Yes.
Okay. Can you blow up this picture a little bit? I know this we were not really focused on the accuracy at this moment, but the capacity help.
So, like zoom more to this graph.
Right. That's fine. Yeah. So I just want to get a little sense.
Yeah, you can zoom in, or even you can just focus on a specific part of the graph.
Right.
And all of the data can be downloaded and visualized in any of your favorite plotting tools.
Right.
And also you can download the graph as well.
Right. I mean, for the project we're doing, we are sending the model, and you're doing the coding and stuff. In the future, can the researcher download the model and modify it by themselves?
For now, if there is any changes in the model, it should be through the JS code, and I think it is easy. They can pass it to me, and I can make the changes.
Yeah, I understand this. I know we are planning to do that because if we are thinking about this, we probably need to do more kind of intensively. We won't have the time to develop our own expertise. down the road to promote the platform, especially when I go out to talk about this, would the researcher be able to download and change the code online?
Nazila, can you show them the Traj Match app and show them like where the snippets can be modified within the little boxes?
Right, exactly. I mean, especially in terms of the one we're talking about,
yeah.
If you can show where you might be able to modify the model.
Yeah. So Nazila, just open trajmatch.distributed.computer and show them the snippets where I think it's the deterministic model itself can be modified. So here's an app that's similar, but you can literally edit pieces of the code within the application. So here, this is sort of like the data and the time intervals, but the deterministic model can also be modified by the researcher to repurpose the application to do a variety of other research.
So they can do the modify this code
yes.
online and by themselves.
Yes.
Okay.
So there's obviously there's a lot of grounds that this can cover. Yeah, the code can be repurposed for a variety of different applications and models and whatnot. And this is something we're interested in pursuing with you and other researchers and students and groups. So thanks. No, we see all this data that's already been produced in the time that we've been speaking. Obviously, the more CPUs we hook up, the faster this goes, and you can do research faster. So I'm just curious to have your just some quick feedback. I mean, we're going to give you this to play with, and Kyung-ya can use her own data and explore and play with the program and give some feedback. But I'd be curious in getting your initial impressions on what you think this might do for this type of research now versus before.
Now, for me, I mean, the Kyung-ya can probably tell you even more about the computational need. I found it fascinating, and Nazina, no, Felisa, a group of us had to drive to Kingston and to force her to hike into the Midas computing core to run some simulations that we need urgently. So we will not. You cannot rely on the existing computing facilities in Canada to do this kind of science in real time, because this, I think, one of the things is you can have access. My understanding, you can have access to this platform anytime, which is important. So I think the whole country, those people are building and funding this high performance computing does not realize that we need, when we do the research, we need to have access to that in real time. We cannot wait for another 2 days to decide to get grant access to a computing facility to run simulations that way. That's not how it's functioning with modelers, and Nazina probably know about this.
I agree.
Yeah, so I think this, for me, this is the major advantage. So the research has the control of the time using the facility, and of course they can decide on how intensive they would like to use their own credits. But that's another story. But in terms of have real-time access to run and test, and to, again, I want to emphasize, to be able to modify the code by themselves, it's really impressive.
Perfect. And in terms of allowing people who are experts in the science, but not so much experts in coding, the ease of use of a platform like this, and the ability to visualize and to share, and also to promote open science. My own research in physics, what I'm excited about is sharing literally a link in a website that allows anybody in the world to go and verify my results and recompute them and test them.
How can you do that, by the way? So if you give them a link, how they can run? Do you have to run on your own whose credits? So
if someone else wants to run this application, they need their own private key store. That's the one I gave you, and only you own it.
Right.
So only you can use it to deploy. But if someone else has their own key store,
right,
they could also run these applications. So it's essentially to protect the volume of compute that you can do. And so no one else can use your compute. So if you share that key store with any of your students, then they can use it as well. And so it allows for the controlled sharing of computing resources. And same goes for us. And we're looking at ways in the future of creating sort of master accounts that can be subdivided into different participants who can use it and so forth. But that's good. So I'm really happy that I mean that's our vision, is to put a distributed supercomputer at everyone's fingertips and also make it very easy to use. I think this will save time for researchers and whatnot. We're very interested in talking with YorkU IT staff to set up a computing cluster there using their idle desktops, in research labs that they're doing nothing 80% of the time, and then hooking those up to serve your app and other apps. We're very interested in speaking to any of your colleagues in any discipline to start building more applications and really promoting the use of the distributed compute protocol. And we're very interested in speaking with GSK. What would really be good is if we could get in on a very large project that would help accelerate our path to essentially growing and spreading this platform to other researchers across Canada and the world. And that's sort of, those are the small things I wanted to do. I had one question out of my own interest and curiosity, Professor Wu. And this might seem like it's coming out of left side. I have no intentions here. From a national security perspective, can an application like this be used to simulate pandemics or biological warfare scenarios that essentially aim to understand spreading of diseases within populations, whether they're accidental or deliberate?
Yes, that's my question for you, Dan. So how are we going to store the data? So my understanding now is if I want to run this, I need to, should I store the data? Now, of course, we send the data to Nazina. How the data is stored?
So the data, when it goes to the compute clusters, it exists only in RAM when it's being processed, and nothing is stored. Nothing is stored on the network. To make this even more secure, this sort of emphasizes the security requirement or imperative to speak to York University, because if they hook up computers that you know that are within York's purview and management, then you know that your data is not leaving the campus.
So this is still running kind of locally. It's a cluster thing.
This is running on about 100 cores here in Kingston.
I know right now it is, but if I manage to get, say, 10 apps at York, contributing to core and so forth, so if I run my code, I'm using their computing only, the facility only.
That's the power of our network, is that we can assign any machines and on a permission basis as required, so that compute gets run in known places. So like that, you don't have to worry about data going to a phone in Vietnam, for example. So that we have the ability to direct the flow of compute on specific networks.
So if because we're running this emergency simulation facility, so itself has only 2 clusters, and we are relying on IBM cloud computing platform, which is no idea. Everybody knows IBM. No, that's not really academic friendly industry. So we run an issue that we keep buying clusters. Computers to store our data, and we don't really like to store in cloud, and especially the emergency rapid simulation data. Yes. But in real situations, with those data, those part of data which are highly sensitive are very small. All the information we need to run the simulation are coming from all different sources. Those are relatively publicly available. It's only how you integrate the data. So there will be one small portion of data that you want to store in a particular machine, if, for example, sitting in my computer. So that's possible. That data is only being used but not stored anywhere but my.
Correct.
So that's very important.
Yes. Yeah. No, we agree. And the other thing, I was just curious. since TB model and TragMatch and similar software can model the effects of infectious diseases propagating within populations, can these models be used to almost determine conditions that would essentially overwhelm a nation state's ability to provide a health intervention to counteract the eruption of a pandemic?
Yes, actually, you might even think about instead of a pandemic. That's the project we are launching. We are working with GSK, and this is in collaboration with Lyon, the French city public health, and it's really to do the real-time forecasting of flu, not necessarily pandemic. So that's a way of testing it.
Mm-hmm.
So we are hoping to entering the CDC, US CDC's national annual flu forecasting competition. So this platform, I mean, we might not necessarily need to make a major change from what is already available on your website. So one way I can ask my assistant to test using the data that we're running. Those are data from Lyon, and those are data from US. Those are not confidential data yet.
Perfect. Well, thank you so much. Now it's over to you to play with this and explore with it, and Nazil will gladly help any of your students or colleagues play with the model. I think I remember hearing 2-3 simple changes we can make really quickly to the model so that it displays the best parameters, and away we go. Professor Wu, it was an absolute pleasure. I'll connect with you separately by email.
Exactly. So I propose that you and I talk a little bit about how collectively promote this, and how I can share with you some of the cost and how we can go out for future funding. But I think we can leave this to Kyoga and
yes,
Dina to work on this. Nazira, actually, we do have now 3 provinces of data. Each province has about 20 counties. We're looking forward to really run the model and do in a relatively short time scale. Are you talking in the CMS meeting?
Yes, thank you for giving me the opportunity.
Are you talking about this?
Yes, I'm going to talk about this.
That's fantastic. So let's try to aim to have something produced so that we can really show to that group of people the power.
Wonderful. Thank you so much. Have a great day.
Thank you. So then we'll follow up quickly.
Yes, we will. Thank you.
Thank you.